Now let's look at nonlinear systems of equations. Now, word of warning, this is the only time the entire chapter we will look at nonlinear systems of equations. So this is the only time we're looking at curves. Once we start 6.2 and for the rest of the chapter, we're looking at lines again. So in nonlinear systems of equations, things get a little more complicated. If it's a nonlinear system of equations, we're basically going to use substitution and elimination in various ways just to try to get it down to one variable. Because once it's down to one variable, I can solve for that variable. So I usually like to try to use elimination first. If that doesn't work, then I can try substitution, and then I can try a combination of them. But the whole goal is to get an equation in one variable so that I can solve for that one variable. Now, a very important line in your notes. When it comes to nonlinear systems of equations, you can get fake answers, which means you do need to technically check every answer you get into both equations to make sure that it works for both equations, which does tend to make for a lot of work. However, let's get started right here with 3a. Now, before we get started, I would like you to practice visualizing, and yes, I'm going to take you back to conic sections for a little bit. Hopefully you realize that that is a circle. X squared plus y squared equals 4 is a circle with radius 2. That is going to be an ellipse. We know it's an ellipse because the coefficients are different numbers. If the coefficients are the same number, that's a circle. Coefficients are different numbers and we're adding. If it was subtracting, it would be a hyperbola. So here we have a circle and we have an ellipse, and we need to find if this circle and this ellipse intersect each other, if they have any points in common. So you can start to visualize what's going on here. If I have a circle here, I could have an ellipse that goes like this, and I'd get 4 intersection points that they have in common. Or we could have a circle and maybe our ellipse looks like that. And now we only have 2 intersection points in common. Or maybe the circle and the ellipse are totally off from each other and they have no intersection points in common. There are lots and lots of different options that we have here. We could even have a circle and the ellipse just barely touches it to get 1 intersection point in common. So we're going to go to solve this. We can use elimination, substitution, anything we want. I quickly noticed that if I multiply this top equation by -4, elimination works out pretty well for us because then our x squareds go away. So I'm going to do that. Multiply everything here by a -4. Notice I just copied the second equation down because I didn't change it. And now I'm going to add these equations together because our x squareds go away. -4y squared plus 9y squared is 5y squared. -16 plus 36 is 20. And now I have an equation that only has one variable. So now I can solve for that one variable. And I get plus or minus 2. So far it's looking like I have 2 solutions to this equation. I have a y equals +2 solution and a y equals -2 solution. So I'm going to pick either equation. I can use the top one or the bottom one to plug these y values in and solve for my x values. I'm going to pick the top equation because it looks a little simpler. So I've got x squared plus y squared equals 4. And I'm going to plug those values of y in. Those are my y values. So I get x squared plus 4 equals 4. Solve this out to get x squared equals 0, square root. X is technically plus or minus 0, but 0 doesn't have a plus or minus. And over to this side, -2 squared is also a +4. So once again, I get plus or minus 0 or 0. So it looks like I have 2 points that are working here. The first point is going to be 0, that's my x value, comma my y value of 2. And this one is 0, my x value, comma my y value of negative 2. Now, we would technically we know that these 2 points work for the first equation. So we would need to technically plug these 2 points into the second equation to make sure they also work. Now, I've already done that, so I'm not going to make you do that for the sake of time today, but just know that in general, you would also need to plug those into the second equation to make sure it still works. So now that you've seen an example of this, I would like you to pause the video and try B, and then come back to check your work and see how you did. Oh, one thing to note about B before you go on, notice that this is still our circle, but now this is going to be a hyperbola because they have different coefficients and they're subtracting. So this is a circle and a hyperbola and seeing where they intersect. So take a few seconds, try this out on your own, pause the video, and then come back to check and see how you did. Let's see how you did. I times the top one by negative 4 again, added them together so my x is eliminated. I got negative 13y squared equals 20, and when I went to solve that, I ended up with a problem very quickly because I cannot square root a negative, that's imaginary. So because I cannot square root a negative, I end with a no solution. Now before we move on to our next problem, I just wanted to show you visually what's going on here. Let's look at A. I went to Desmos and plotted those 2 equations, and you can see that we have 2 points where they intersect. Here we go. There's 1, there's 2. The 2 places where this circle and this ellipse intersect. Now, I also plotted these 2, our circle and our hyperbola, and you'll see, there we go, that the circle and the hyperbola do not intersect. That's why there's no solution. So, with that in mind, let's do one more for this video, and then we'll be done with this video. We have this system of equations. This is going to be a circle again. This, however, is a line. Y minus 2x equals 0. That's just a straight line. So we have a circle and a line here. So we could get 2 intersection points. We could get 1 intersection point. We could get no intersection points. But it seems like at most I'm going to have 2 intersection points for a circle and a line. Now, one thing I notice when I go to solve this, elimination is not going to work because I cannot multiply this equation by anything to get these to cancel out. I could try squaring it, but remember you can't square it individually. You can only square it as a whole, which would be my y minus 2x times y minus 2x, squaring that. And that gets really ugly really quickly because you have to FOIL. So instead of using elimination, because it's not seeming to work here, I could very easily use substitution by taking this y minus 2x equals 0, solving it for y, and now I have an equation I can substitute into the other equation. Substitution. So this is where we said at the beginning, there is no one way to solve these. You can use substitution, you can use elimination. We'll see in the next 2 problems in the next video, we use a combination of those things. And so you kind of just have to play around with it until, remember, the goal is to get one equation in one variable. That's the goal. So if I look right here, after I did my substitution, I have one equation that only has x's. One equation in one variable. So that means I can solve this. 2x squared is going to be 2x times 2x, which is 4x squared. X squared plus 4x squared is 5x squared. Square root gives me plus or minus 1. Now, same thing we did last time. It looks like I've got 2 solutions so far, both of them x's. So I'm going to take either equation, plug those values in, and see what I get. Now, if I can plug these x values into either of these 2 equations, I'm going to plug them into this one. Or, even better, this one. That's definitely the easiest equation to plug these in and get answers for. So I plug in 1 and negative 1, and that gives me y equals 2 and y equals negative 2. So those are my y values. So it looks like this circle and this line have 2 intersection points. One at 1, 2, and one at negative 1, negative 2. So let's see what's going on here. We have a circle and a line. There's our circle, there's our line, and just like we got, there's our 2 intersection points. So that is a quick introduction to solving systems of non-linear equation when we have curves involved. In the next video, we're going to start to do some much more complicated versions of these questions.